Hey guys, so today we're going to go over solving trig equations. Again, just like when you're verifying trig equations, the ideal situation to solve them is to also make sure you have everything as the same trig function. So what we're going to do here is if we have everything as the same trig function as we do for number one, I'm going to change all of the trig functions to just say x so that I can see it from an algebra perspective. So anything that says tangent x will just be changed to x. And I want you to keep in mind for this tangent squared x, how they write it. I'm taking a sidebar up here, by the way. So tangent squared x, this is the same thing as saying tangent x squared. It is not to be confused with a double angle where they multiply the x by 2. Since it's just squared, this is the same thing as saying tangent x and you're squaring it, meaning tangent x times tangent x. So just kind of keep that in mind here. So when I'm replacing the tangent with x, it's just going to say square root of 3 x squared, because this is the same thing as saying tangent x squared. So I replace the tangent with x, bring down the squared. And then I'm going to bring down the equal sign, and instead of negative tangent x, it's going to say negative x. So now we have an algebra perspective from this, and this is a quadratic equation because the highest exponent or the degree is 2, and when we solve for quadratic equations, we make sure that one side of the equal sign is 0. So I'm going to add this x to the other side. Keep in mind that on the left, these are not like terms. This one has an x squared, this one has an x, so I don't do anything with them but bring everything down. So square root of 3x squared plus x equals 0. Now, usually you have the ax squared plus bx plus c, and you factor and you can solve by multiplying first times last, so on and so forth. But since there's only two terms here, that means there's only two different ways to factor. One, you either have a GCF, and or two, you have a difference of two perfect squares, meaning you could take the square root of each one of these perfectly, and there's a difference, meaning a subtraction sign. So this is obviously not a difference of squares. We don't have a subtraction sign. I can't take the perfect square root of 3. Um, and I'll get into a difference of squares later just to throw in a quick algebra review. But in these two terms, they have a GCF. Their GCF is x. So if I divide out x out of each one of these terms in the parentheses, and I'll take a sidebar here, square root of 3x squared, if I divide x out, I'm left with square root of 3 times x. And plus x divided by x will give me 1. And just like anytime you factor, if you distribute, you should end up right back to the previous line, if you factored correctly, I should state. So since this is factored and the other side is 0, you can apply what's called zero product property, meaning you can set each parentheses or each factor equal to 0 and then solve for x from there. There's nothing to solve here if I set x equal to 0, but if I set square root of 3x plus 1 equals 0, I'm going to just get x by itself by subtracting 1 on both sides. And I'm going to move this over a little bit. I'll get the square root of 3x equals negative 1. I need to get x by itself, so I'm going to divide both sides by the square root of 3, because x is being multiplied to square root of 3, so to get rid of it, divide it. Now, pretty much x is by itself, but we don't leave a square root or a radical in the denominator. We rationalize it, meaning we multiply it by itself. And this will give me, when I multiply straight across, negative square root of 3 over 3. Remember that we're not done. We didn't solve for x because we changed everything that said tangent x into x. So since we changed everything that said tangent x into x, change it back. Change everything that says x into tangent x. And to solve, we want tangent of some angle that equals to 0. So when you get the trig function by itself, it's time to solve for x or the angle. It's time to bring out the unit circle. Where does tangent equal to 0? So if you look on the unit circle, tangent equals to 0 at 0 and pi. So this is your answer for the first part, and fill in the blank and it works. Tangent of 0 equals 0 and tangent of pi equals 0. So if you replace the x with those two angles, it actually works. Same thing here. Instead of x equals negative square root of 3 over 3, I'm going to write, and I know I'm all over the place on this one, tangent of x equals negative square root of 3 over 3. So again, I'm looking for where tangent equals negative square root of 3, there's a negative here, negative square root of 3 over 3. I'm trying to find the angle. So when I can find the angle, those will be my answer. And when you look at the unit circle, remember your module 4 tricks. All students take calculus. Tangent is positive in quadrant 1 and 3. So I'm going to look in quadrant 2 and 4 for the angles where tangent is negative square root of 3 over 3. One thing to keep in mind, anytime the radian value is over 6, tangent is negative square root of 3 over 3. So that would be at 5 pi over 6 and 11 pi over 6. So those are my answers. Those are my angles. I hope this helps. Since I'm out of room, I'm going to do the other problem on another slide.